Hi everybody. Today we have a question from American Invitational Mathematical Examination and short form abbreviated as AIME. So from 2006 AIME from set A we have 7 problem and this problem is in its own kind of a unique problem. So between equally spaced parallel lines an angle is drawn by taking a point between the parallel lines. The parallel lines divide the angle into a triangle and many trapeziums. Now we divide the angle into some region, the region A, B, C, D. If ratio of area of region C is to area of region B is equals to 11 is to 5, then what is the ratio of area of region D to area of region A? And note that vertex of angle is not on parallel line. So please give your trial to this question and keep watching for the solution. Now here is our figure and we just flip it vertically, but before flipping look at this. If here is a trapezium and we draw a parallel line such that two divided trapeziums have equal altitude, and this is our assumption. Now these two angles are equal by corresponding angles, and these two another angles are also equal by corresponding angles, and we draw altitude in both trapeziums, and these two another angles are also of 90 degrees by co-interior angles, and after subtracting corresponding angles minus 90 degrees we get these two angles are also equal, and we know that altitude of both trapeziums are equal by our assumption. So by AAS congruency rule we conclude that these two right triangles are congruent. Now we can conclude that base of both right triangles are equal by CPCT, and we can do this congruency in the right side of a trapezium, and after dropping perpendiculars we conclude that right triangles on right side have equal bases. Now here is our figure after flipping it vertically. Now let the base of the triangle be A and draw the perpendicular in the trapezium below the triangle, and we know that after dropping the perpendiculars the figure formed is a rectangle. So and we know that opposite sides of rectangle are equal, so the middle side of the trapezium is also equal to A, and let the side on the left side of the trapezium let be B, and the side on the right side of the trapezium let be C, and dropping perpendiculars in the another trapezium just below the first trapezium we know that side on the right side is also equals to C, and side on the left side is also equals to B, because we know that the parallel lines are set on equal spaces, and the middle side of the trapezium is the sum of the above side, which is equal to A plus B plus C, and dropping perpendiculars in all the trapeziums we know that side on the right side is equals to C, and side on the left side is equals to B, and the middle side is just the sum of the above side, and we in the same progression we write the sides of the trapezium. Now we have given that area of region C is to area of region B is equals to 11 is to 5, and we know that area of trapezium is equals to 1 over 2 times sum of parallel sides times altitude. So area of region C is equals to 1 over 2 times A plus 3B plus 3C plus A plus 4B plus 4C times altitude, and area of region B is equals to 1 over 2 times A plus B plus C plus A plus 2B plus 2C times altitude. And after putting the values, 1 over 2 times 2A plus 7B times plus 7C times altitude divided by 1 over 2 times 2A plus 3B plus 3C times altitude is equals to 11 is to 5, and cancelling 1 by 2 and altitude by altitude, because both trapeziums have equal altitudes, because both are placed between equal spaced parallel lines. So 5 times 2a plus 7b plus 7c is equals to 11 times 2a plus 3b plus 3c, and after opening the brackets, 10a plus 35b plus 35c is equals to 22a plus 33b plus 33c. So finally 2b plus 2c is equals to 12a. So b plus c is equals to 6a. Now observe this triangle. In these small triangles, let the altitude be h. So in another figure, this altitude is also equals to h, and let the altitude of trapezium be h dashed, and we know that these both triangles are similar. So by similarity rule, h plus h dash divided by h is equals to a plus b plus c by a, and we know that b plus c is equals to 6a. So 1 plus h dash by h is equals to a plus 6a by a. So 1 plus h dashed by h is equals to 7a by a, and cancelling a, so h dashed by h is equals to 6. So h dash is equals to 6 times h, and we write this result in the corner. Now here is our figure, and we have to find area of region D divided by area of region A, and region D is a trapezium. So area of trapezium we learned at 1 by 2 times sum of parallel sides times altitude. In this case, we let it h dash divided by region A, which is a triangle, and area of triangle is equals to 1 by 2 times base times altitude, and we let that altitude is h, and we note that after the substitution we get 1 by 2 times 2a plus 11b plus 11c times 6h by 1 by 2 times a times h, and cancelling 1 by 2. So we get this 2a plus 11 times b plus c times 6h divided by 2 times h, and cancelling h, we know that b plus c is equals to 6a. So 2a plus 11 times 6a times 6 by a. So area of region D by area of region A is equals to 68 times a times 6 divided by a, and cancelling term a. So area of region D is to region A is equals to 408 divided by 1, and that is our correct answer. After huge search on internet and after reaching the dead end, I conclude that my way of solving this AIME problem is the most easiest way of solving this, and I hope you would love that.